In this video, I'm going to be covering the topic of conjugate acids and bases. So if we see an acid HA, and this can denote any acid with a hydrogen willing to be donated, what we can see is when we donate this hydrogen, this acid will now be left with simply A minus. This is called the conjugate base. Basically, a conjugate base is what's left over after you donate the hydrogen from the acid. So an acid has a hydrogen to give, it gives away that hydrogen to a base. What's left over is the conjugate base. Now, the conjugate base could then take a hydrogen and become the acid again, and we could see an equilibrium reaction like that. If we see a base with a lone pair ready to accept a hydrogen, once we see that base accept a hydrogen, we will now call this, the base will now have a positive charge. This will be our base. This will be the conjugate acid. So basically, for a base, after we use that lone pair to accept a hydrogen, that base now has a hydrogen that it could donate. So it is the conjugate acid. You could almost think of a conjugate as what is left over from the acid or base reaction happening. So for an acid, when it donates a hydrogen, it is now the conjugate base. When a base accepts a hydrogen, it is now the conjugate acid with that hydrogen now attached to that base. Now, it is very important to understand conjugates in terms of the strength of our acid or base. So I'm going to make this demonstration using an acid, but it goes the same way for a base, and I will put questions after this lecture for acids and bases. So if we have a strong acid, so HA we will call our strong acid. So this strong acid wants to donate hydrogen 100% of the time. Why does it want to do that? Well, what we can see is that a strong acid really wants to donate that hydrogen because the conjugate base that is left over will be really stable. So we can say this conjugate base is very stable. So if you are the strong acid, you are thinking, I really want to donate my hydrogen because I know once I donate my hydrogen, my conjugate base that will be left over is very stable and happy. So I want to do something that is going to make me stable. So this strong acid will donate that hydrogen 100% of the time, I should say, so that it can reach its stable conjugate base. So that is why it proceeds with 100% yield. Now, what about a weak acid? A weak acid will donate this hydrogen less than 100% of the time. And as we saw before, it is much less than 100%. So why is there a discrepancy between a strong acid and a weak acid in terms of donating its hydrogen? Well, the conjugate base that the weak acid will form is not as stable. So if you are a weak acid and you are going to donate your hydrogen, you really wouldn't want to donate your hydrogen as much as a strong acid would, because you know the conjugate base that is going to form once you do so is really not as stable in comparison to the conjugate base of a strong acid. Now, there are weak acids that are a little bit stronger than others, but we classify a weak acid that its conjugate base is not really that stable, because if it were that stable, it would be a strong acid where that strong acid would want to donate that hydrogen 100% of the time to get that very stable conjugate base. So knowing the difference between a strong acid and a weak acid and understanding that it all has to do with the stability of the conjugate base is very important when you go to answer a question that has to do with acids and bases, because if you treat a weak acid like a strong acid or a strong acid like a weak acid, that will completely change how you approach solving this problem.